Hey everybody, this is Ripley back again. Oh, now we're in the thick of things. In section 2.7, this is called derivatives. We're finally going to give this thing, this limit as x approaches a of f of x minus f of a over x minus a. And it's exactly the same thing as the limit as h goes to 0 of f of a plus h minus f of a all over h, which we know is equal to the slope of the tangent line. The problem is that writing these out, we're mathematicians, so we're lazy and we need names for things. We're finally going to give this thing a name, and that name is, you ready? F primed at A. This is referred to as the slope of the line tangent to f of x at x equals a. Yay! So these are now consolidated into that notation. And that's literally it. We have a new way basically to talk about this, we've got this uncumbersome way. So if I see, think about this. If I'm talking about anything, if I've got any function at all, if I've got, I don't know, call it whatever you want. If I've got h of x equals 9x to the fifth minus the natural log of x minus 3x squared, and I talk about h primed at 17. All right, now we don't quite have the wherewithal to be able to start taking the derivatives of things like this yet. All right, taking the derivative is the process of going through the limit. Okay, now down the road I will give you shortcuts, but for now, unfortunately, when you speak of Ripley, by God, you better speak highly. For now, you're going to have to do it by hand. Okay, even though that kind of sucks, it is what it is. We'll go through one of these by hand really quickly. All right, even though it's very simple. All that this means is the slope of the line tangent to h of x at x equals 17. Now, it doesn't just mean that. Let's make sure we understand. This is the key thing, because you're going to have this running dialogue of vocabulary words going through your head if you want to be comfortable with this. It also means this. It means the instantaneous rate of change. In other words, it tells me how quickly this thing is changing. All right? Rate of change of h of x at x equals 17. All right? Now, so think about that in your brain. If you're looking at something and you're like, okay, what does h prime of 17 mean? Well, the first thing that should pop into your head is, oh, it's the slope of the line tangent to h at x equals 17. Oh, wait. But it's also the instantaneous rate of change of h at x equals 17. Oh, wait. It's also referred to as the derivative of h at 17. So all of those phrases, all of those terms are going to have to be interchangeable. You're going to have to be fluent. You're going to have to, just like I preach fluency in graphical, numerical, and algebraic techniques with calculus, you're going to have to be fluent in jumping back and forth with notations and definitions and things like that. So, for example, let's let f of x equal, I don't know, we should make it kind of juicy, right? Let's go x minus 2, okay? If I say find f primed at 1, all right? Notice, I'm not asking for the slope of a line tangent. I'm not asking for anything. I'm saying simply find the derivative. That's it. Well, the first thing that should pop into your head is, all right, I'm going to find the instantaneous rate of change of f at x equals 1. Or I'm going to find the slope of the line tangent to f of x at x equals 1. Now, I may or may not use that, but that is what it is. Let's go through the process, okay? So f prime at 1. I am always a bigger fan. What's going to happen is you're going to be able to choose which way you like to do these things best. However, you're going to have to be able you're going to have to be fluent at identifying both of these terms. Let me rewrite those. Both the terms, the limit as x approaches a of f of x minus f of a over x minus a, and the limit as h goes to 0 of f of a plus h minus f of a all over h. And you have to be able to identify both of those as f prime of a. That's the key. This is the one typically that I like to work with the best. Theoretically, if you did enough algebra, either one of them would work, but this is the one I like to do best. So let's find f prime of 1, just for giggles, okay? I'm going to take the limit, as x approaches 1, remember, that's a, of, you ready, f of x. So I got 1 over x minus 2 minus f of 1. I better find f of 1. So f of 1, because the formula requires it. See, this is f of a. F of 1 appears to be negative 1. So this is minus negative 1 all over x minus 1. Now again, if I throw in x equals 1, I'm going to end up with negative 1 plus 1, which is 0, over 0. So it's time to do some algebra. Let's clean this thing up. I'm going to get the limit as x approaches 1 of, let's see, 1 over x minus 2 plus 1 over x minus 1. Find a common denominator and let's see what happens. The limit as x approaches 1 of 1 plus x minus 2 over x minus 2 all over x minus 1. Okay? Now watch what is about to happen here. I hope I have enough room. If not, I'll pop over. I get the limit as x approaches 1 of 1 plus x minus 2 is x minus 1 over x minus 2 over x minus 1. Remember this? If these guys are 2 away, those cancel. Now careful, there's a 1 up here that we got to be a little bit respectful of. So I end up with the limit. As x approaches 1 of, what was it again? 1 over x minus 2. Look at that. This is equal to f prime at 1. Isn't that cool? Now, it's a coincidence that this value and this value are the same. That happens. It's the process that you have to go through. Had we taken this at any other point other than x equals 1, and clearly at x equals 2, that wouldn't work, right? But if I'd taken it at 3, it would have been a different value. All right, now let's talk about this for just a second, and then I'll be done. This is a really short one. What did I say? F of x equals 1 over x minus 2, right? Ooh, wow, look at that. Isn't that crazy? This function, that's nuts. When it completed itself, as it were, I didn't even realize that I invented a function that sort of gets you back to itself. That's crazy. Sorry, I'm tripping out on that. All right. Anyway, it's you know what? Just let's do exactly the same thing. Only let's find f prime of 3. It's not a bad idea to go through it one more time. Okay. If you think you got it, then well, let's do it anyways. All right. F of x equals 1 over x minus 2. Now, you ready? So first things first, I might want f of 3. Well, f of 3 is positive 1. Okay. Excuse me. Wait, do I want that? Do I want that? Let's do let's not get crazy. Let's do f prime of 4. Sorry about that. Maybe I'll try and go in and edit that out later. Let's do f prime of 4, because then it won't be as crazy. I have this weird vertical asymptote. If I'm going to try and figure out what the derivative is, then I need to know what f of 4 is, and that's easy, right? That's 1/2. So I know that f prime to 4 is the limit as x goes to 4 of 1 over, remember it's f of x minus f of a, so this is 1 over x minus 2, right? Minus, well, we know that f of 4, that's going to be 1 over 2 over x minus 4, right? That's always nice, because I know this guy, whoop, goes right in here. That's what a is. Now let's do just a little bit of algebra. And I'm going to go x goes to 4. I'm going to find a common denominator, so I end up with 2 minus x plus 2 all over 2 times x minus 2 all over x minus 4. Okay? Now, this is actually a great problem. I kind of lucked into this one. Check it out. If I take the limit as x goes to 4, what do I end up with here? I end up with 2 plus 2 is 4, 4 minus x. But remember, our trouble here is this value, this chunk. I need that to cancel. So what I need is an x minus 4. So if this thing's going to turn into a 4 minus x, and I need an x minus 4, I just factor out a negative. So I'll end up with negative times x minus 4 over 2 times x minus 2 over x minus 4. Now these guys are 2 apart, so I get to cancel them out. And this ends up being the limit as x approaches 4 of negative 1 over 2 times x minus 2. Now watch what happens when I stick 4 in for x. Now I can plug it in because these canceled, so I don't end up with a 0 in the denominator. I end up with negative 1/4. And that guy right there is equal to f prime of 4. That's cool, huh? That's pretty fun. All right, I hope you enjoyed that. We'll go over more of it tomorrow in class, and we'll do a whole bunch of these. So thanks for your time and attention, and have a really good day.